Assalamualaikum and good day. My name is Wanufatin Alia Mazira binti Wan Kamaluddin. My student ID is 2020498996. My course code is AS253. The title of my project is Absorption Studies of Graphene Oxide towards Hydrocortisones in Water Sample using High Performance Liquid Chromatography Hplc. There are three problem statements in this study. First, because of their low concentration and small size, steroid hormones are difficult to detect and remove. And second, solid phase extraction has been widely developed. However, it is a time-consuming technique. And third, the selection of solvent is important in dispersive micro-solid phase extraction to ensure effective adsorption. There are two objectives I tried to achieve in this study, which are first is to optimize D-µSPE using graphene oxide coupled with high-performance liquid chromatography Hplc. Second is to validate and apply several D-µSPE parameters such as sample pH, mass of sorbent, and volume of desorption solvent. The significance of this study is D-µSPE enable more samples to be examined at once and also a relatively fast technique. Furthermore, it is a green method because it uses less solvent, which can lead to the reduction of waste product. Hplc is usually used in steroid hormone analysis because it is an effective separation and quantification method. Thus, this method merges all the desired requirements for a rapid, sensitive, and reproducible for detection of hydrocortisone in water sample. Hydrocortisone is a synthetic steroid from glucocorticoid group. Exposing to this steroid may endanger human and aquatic creatures. D-µSPE is efficient in recovering steroid in meat according to the study of Song and Feng in 2021. It is due to the solvent dispersion that can improve extraction kinetics. Thus, sorption and elution kinetics also improve. Based on Plotka-Veselka et al., the equilibrium rate is increased and extraction yields are higher in D-µSPE is due to the contact between the target analytes and the support is greater compared to traditional SPE. Graphene oxide has large surface area and hydrophilic. It also provides high stiffness and high stability in various types of solvent or temperature. This is a summary of previous study in extraction of hydrocortisone in various types of sample. First, Nakajima in 2015 applied SPE technique coupled with LC-MS. Second, Arif and Atta prefer solvent extraction coupled with RP-HPLC DAD. Lastly, Siu et al. Use SPE method and UPLC-MS. Our HPLC instruments are optimized as above. The column temperature is maintained at 38 degrees Celsius and flow rate is 0.5 ml per minute. The mobile phase is UPW and methanol in 15:15 ratio. Micro-SPE procedure was carried out in this sequence. The next parameter was optimized after the previous one was successfully optimized. First, mass of solvent was varied from 10 mg to 14 mg. Next, water pH are adjusted to pH 5, 7, 9, and 11. Lastly, volume of desorption solvents are varied to 0.2, 0.4, 0.6, and 0.8 ml. This is the general flowchart of this study. First is preparation of stock solution and working solution. Next is identification of hydrocortisone peak using Hplc DAD. Then optimization of dispersive micro-solid phase extraction parameter. And lastly is method validation. The retention time of hydrocortisone was found between 2.4 to 3 minutes. The peak was prominent and sharp, indicate that the Hplc condition was successful. The presence of hydrocortisone in water sample was confirmed by comparing the retention time obtained in sample with standard injected into the Hplc. The calibration curve was found linear in the range of 15 ppb to 400 ppb. It also showed a good linear regression with equation of y equal to 0.0186x plus 0.1519. The calibration curve produced correlation coefficient of R squared of 0.9849. Amount of solvent was vital in D-µSPE effectiveness. The mass of 20 mg of GO gave the best result compared to other mass since it has highest peak area. The peak started to decline at 30 mg. This result suggests that 20 mg of graphene oxide can provide enough active site for the absorption of hydrocortisone. The analytes form can be vary if the pH is changed. The analyte adsorption onto the solvent and solubility in the aqueous phase may be affected by protonation and deprotonation. The optimized pH of this study was found to be pH 9 because the carbonyl group in GO are protonated, causing the GO sheet to dissolve in water. Ultimately, the optimized volume of desorption solvent is 0.6 ml with maximum peak area compared to other volume. This is due to the enhancement of hydrocortisone extraction recovery. When the volume of desorption solvent increased to 0.8 ml, the chromatography peak begins to drop is due to increase of attraction of hydrocortisone to aqueous solution caused by a decrease of polarity, resulting in a reduced hydrocortisone extraction recovery. The optimum condition for hydrocortisone extraction achieved from past experiment were used in method validation. The linearity step was established using 5 different concentration which was in between 0.05 to 0.4 mg per liter. The linearity of the step showed a good coefficient of determination R squared value which is 0.9718. The LOD and LOQ was detected in tap water to be 10.2386 microgram per liter and 34.1286 microgram per liter respectively. Hplc chromatography technique offer environmentally friendly, sensitive, accurate, repeatable and specific method for routine hydrocortisone analysis. Graphene oxide solvent achieve high selectivity. Dispersive µSPE technique detect minimal hydrocortisone in tap water. The method is quick, effective and reduce harmful solvent usage and waste product.